everyone. Today we will do 6.5 properties of logarithmic. So in the properties of logarithmic, we are writing it works for the every base, whatever the base. Base can be 10, exponential, e, that you will write, ln, natural log base, and another base. Okay. So I'm writing for log log. Log x times y. If two terms are multiplying, it can be a constant or it can be variable. You can expand it log x plus log y. The next is if the two terms are dividing, it's a quotient property. If the two terms are dividing, you can write log of the first term minus the log of denominator term. Now we have a power property, log with base 10, and then you have a x power y. The power of x is given as a y. I can write y shifted down log x here. These are the basic important properties in the log in this chapter. Let's start with the A part. It says log base 2 of 3 over 7. Which property I will use? Quotient property, because it says something in a rational form, 3 over 7. It will be log base 2 of 3 minus log base 2 of 7. This value is given 1.585 and this is given 2.807. We can simplify and we'll get negative 1.22 and 2. Let's do this one first. Log base 2 of 49. 49 is nothing given. Can you split 49? You can write 7 power 2. 7 power 2. So which property will use? Power property. Power comes down log base 2 of 7. You have the value of log base 2 of 7. 2 outside. It's 2.807. If I multiply, I will get 5.614. Now let's do the second. Log base 2 of 21. Can you split 21? 3 sevens are 21. 3 7 in multiplication. Okay. I can say log base 2 of 3 plus log base 2 of 7. And this is 1.585 plus 2.807. Both values are provided. If I write the value, I will get 3 point. It is 4 point. .392. Done. Next, expand it. Okay, see this. If you are going to expand, I will convert this left side into right. If we are going to expand, left side converted into right. Check it. How many terms you have? You have total 2 terms basically. First and the second. So let's apply the quotient rule. Ln of numerator minus ln of denominator. Whatever log used, you have to choose the same. You cannot choose different. Okay. Now see again. It is different. It's not a single term. You have a more than one term here. It is 5 and power 7 as well. The power is also here. Power is 7. So first I am applying the product property. Log 5 plus log x power 7. This log y is it. Here I am applying the power property. Power goes down. It's this. Done. We expand it. See, how many terms are there? Your last term contains that many terms. 1, 2, 3. You also contain 1, 2, 3. Okay. Next, we have to condense it. When we are going to condense, we will shift the right side values into left and make sure your answer contains single log, not more than one log in the answer, in the condensed form. And another thing to check, all logs will be same. It's not like one is a natural log, another is a different log with different base. Okay. What I'm doing, I am shifting the powers back. This is 3, I'm shifting it back. So it's log 2 power 3 minus log 4. I'm applying the 1 by 1 properties. If I apply in this, the values are adding. So that means in the condensed form, they will product 9 times 2 power 3. 2 power 3 is 8. So it's 9 times 8 minus log of 3. If the values are subtracting, that means you have to write in a fraction form. 9, 8 over 3. Don't write log again. I told you log will be only one time. 3 3s are 9. 8 3s are 24. So you will get log of 24 as an answer with the condense. Okay. Next we have this change of base formula. In the change of base, something is written like log base b of x. Two terms of changing they will ask generally. Change in the common logarithmic or change in the natural log. If they say change into the common log, you will say log x over log b. If you are converting into natural log, it will be natural log of x over natural log of b. Anyhow, the value of all three will be same. These all three values are same. This representation is different, in which we write as a common logarithmic. Here we write in the natural log. We have a question. Let's start it. Log base 3 of 8 using common logarithms. If I use the common logarithmic, it will be log 8 over log 3. Done. The next, we have to evaluate log base 6 of 24 in natural log. Ln of 24 over ln of 6. Don't cancel. 2 3s are 6 and 2 12s are 24. It's like that. No, we don't need to cancel here. We cannot cancel in the terms. Okay, so it's log base 6 of 24 converted into natural logarithm. Next question is, for a sound with the intensity, the loudness of the sound is given in this form, where I note is the intensity of a barely audible sound. An artist in the recording studio turns up the volume of a track so that intensity of the sound is double. So I want I to be double. Double means 2 times. How many decibels does the loudness increase? How much increase I have so it becomes double? Okay. Let's find L of 2i because I have to find double of intensity. So 10 log I change into 2i and then over I naught. I have to find how much I need to increase. So I will find the difference. L of 2i minus L of I. 10 log 2i over I naught minus 10 log I over I naught. Here I can use the property. I can write 10 log base 2 plus 10 log, it is 10 log I over I naught minus 10 log I over I naught. So what I did, see, I use the product property here. 2 and this as a second term. This is the first term, this is as a second term. So product property is log of the first term plus log of the second term. Okay. If you see this getting cancelled, so what you are left with? You are left with 10 log 2. The answer. So I will say we have to increase the loudness 10 log 2 decibels. Okay. We have to increase 10 log 2 decibels so the loudness increase to double. Okay. So we are done with the 6.5. I hope you understand. Thanks for watching.